So I'm Jere Heikkinen, the CEO and the chairman of Finnos, and we claim to be the forerunner of sawmill digitalization. And today I will relate the topics of photonics to the digitalization, how the photonics actually enables it in the sawmill. Okay, Finnos might be a somewhat unknown name, new to someone. We established Finnos just 1.5 years ago. We are established at Lappeenranta, Finland, where all the essential development, design, assembly and manufacturing takes place. Our business is based on Bintech from the X-ray side. Bintech might be more familiar name for some of you. It's a pioneer in the X-ray technology in the Europe, started from 1988. And we acquired the business last year, and since then we have expanded in the technology and in the number of resources as well. At the moment we are a team of 20, and we are growing. We are seeking for more talents. We are mostly from the University of Lappeenranta. I think 60% is from there. So one can say that we are kind of a spin-off of LUT, Lappeenranta University of Technology. And most parts of the X-ray research have been conducted at LUT. When we established Finnos, there was a nice break in the business. And that's typically a good point where to kind of gather ideas and discuss with the customers and draw new technologies into the existing ones. So this was kind of the first stage of the development after almost 100 meetings with customers, potential customers and so on. It's a measuring station. Every equipment almost is included in that container. It's a solid container structure. It's temperature isolated, radiation shielded, temperature stabilized. It's weatherproof, so you can install it under the sky. It's pretty fast to install also. It's modular and straightforwardly upgradable, so we can meet different demands from different customers easily. It incorporates X-ray technology, laser scanning, and also we use cameras to measure color images from the logs. So this system is used at the log yard in the log sorting. Something about the raw data. Firstly, of course, we knew the restrictions of X-ray technology from the Bintech side after 10 years of hard work and development. So we knew that one technology is not enough to solve all the problems required at the sawmill. So we need really accurate 3D point cloud from the log surface. We need accurate color images around the log. And we need, of course, X-ray pictures, as many as needed. Typically, we install 2. And then we do some, let's say, magic tricks, tomography, data fusion, and stuff like that. But this is the base. And then not only look at the point cloud, but also we analyze the laser scattering of the point cloud. So each of the points will be analyzed, and the pattern of the scattering will be analyzed as well. This is a log on the left-hand side. On the right-hand side, there's a laser scattering analysis visualized like that. So pretty well, we can identify which of the laser points are on the bark or on the subwood. And this is essential in Finland because the payment of the log is, well, it's on the bark, and if it's missing, it needs to be computationally added. And of course, it makes sense to try to estimate the volume of the missing bark really accurately. Also, we detect snow and ice. The same techniques are used. So these are used for the payment as volumes, and then of course we try to analyze all the harvesting damages as well. The X-ray part of the system, it's based on Pintex technology. More than 10 years of development with the University of Lappeenranta. And this is a rough illustration of the sparse angle tomography from really small amount of data. And this is done in real time in the sawmills right now in our systems. So this is kind of the basic background, which is background engine which is running in the system. And then we go to the data fusion. We kind of combine all the available information into a mathematical model. We use correlation priors to kind of build artificial log model. We use the laser points, we use the scattering pattern analysis, and we use the color imaging results in order to come up with a kind of virtual log. We go under the bark, which is essential in terms of sawing. Sawmill wants to saw the wood, not just the bark. So we have to see under the bark already in the log sorting, and we have to classify and bin the logs accurately. And then we go inside the log, internal features, knot volumes, density, annual ring width, hardwood, and so on. Also the geometrical properties, skewness, and stuff like that. Everything will be analyzed. Okay, now the sawmillers, they have a kind of Ferrari, and now they need a steering wheel. So we need kind of advanced simulation tools in order to steer the production. All the customer end products are included in the simulator. All the quality distributions measured by our system is included in the simulator, and so on. Everything is steered from this simulator side. And well, the most important thing is that we can actually start simulating the log stock on the log yard. Not just the sowing, but also the value yield. Then this is something customers wanted. Well, basically it's just a navigation system for the forklifts in the log yard. It's pretty essential not to drive around too much. It's essential to be efficient and try to work on the log sorting and the sawmill side efficiently. All the technologies are developed on the 2017 architectures. Everything is web-based, responsive. It allows simultaneous client connections, individual user profiles for operator, production planner, and even the sawmill manager if there's any need. But everything is included. And this all is kind of preparing us for the future. We want to be the forerunner of sawmill digitalization. These are the terms related to or associated to the digitalization. The last one, reinforced deep learning, that's something we are going towards, and probably, or we have actually used it already, but in different environments. This is a typical path for the logs. They come from the forest through the log reception, log sorting, to the log yard sowing, and eventually to the board scanning and to the customer eventually. We want to close this loop from board scanning to the log reception. We want to build a feedback loop. That means that we can give the output of the board scanning as an input to the log sorting, which gives us or enables us to build a reinforced deep learning system. It's kind of self-learning or self-tuning system. And these are the steps around it. Of course, the software development. That's what we are headed. And then the system which is now built for the log sorting will be developed further for the sowing in the saw line. And actually, it was already tested in last July with quite positive results. We have an ongoing collaboration between LUT, MIT, York Electronic from Germany, and Holtec. And then we are looking for partners from Finland, research partners, industrial partners, and so on. And then last week, we kicked off this feedback loop project. It's a Tekes-funded project with LUT, also MIT, Stora Enso, Finnos, and Finskan. It's a 2 years project where we built this feedback loop in one of the sawmills in Finland. And then this is the kind of last step. We want to build a feedback loop to the forest too. We want to have the GPS coordinate the quality of each of the trees in that GPS coordinate and bring it to the sawmill, bring it to the port scanning and back. We want to be part of that, building that kind of data flow back and forth. That's it. Thank you.
Thank you, Jere. Now it's time for questions.
Okay, Teppo from Stora Enso. So, how was do you have any mechanic experience from the forest end? So, do you have make any X-ray machines to the forest or machine vision or etc.?
Not to the forest, but of course we are open to it. And actually in the fourth stage, where we want to find the forest quality, there is some ongoing discussion to come up with a project where we build an X-ray system to the forest.
But it may be a bit expensive to be in forest.
Well, of course, if it needs to be in the every harvester's hand, let's say, then it would be expensive. And also, I guess the Finnish radiation safety officers would be quite against it. But there is always kind of a workaround. In the first stage, we would gather a lot of data from different places around Finland, measure the logs on site with X-ray and laser and stuff like that, and then try to combine with all the information is at the moment available from the harvester hands, and then find a correlation with, for example, knots.
So, is there already existing machines in the harvester edge which can provide the information you need?
I think there is some sensors already in, and I know that there is coming a lot of more technology, cameras and stuff like that, which of course would be useful to connect as a data. But probably X-ray is kind of a dream. It has been a dream, and I guess it will be a dream. Those environments are maybe too demanding for having an X-ray in every harvester. Yes, I'm quite positive that not one technology solves actually anything. We need a hybrid data fusion always.
How about the data processing in the forest? Maybe there's a certain limitations when it comes to the computing power.
Well, nowadays the basic GPU cards can be embedded into quite small computers already, and that brings teraflops of computing power, and those kind of machine vision problems typically are those that can be distributed to thousands of cores. So I don't see the computational task as a demanding task, even in the forest side.
Any other questions?
How do you measure the annual rings?
With X-ray. They are actually visible just in one X-ray picture.
Yeah, one question. Probably you already kind of explained it, but to summarize, there was this roadmap picture you had, this optimizer, that was the second step. Can you slightly elaborate on that again? What was it about?
Okay. Well, it's essentially similar kind of system than in the log sorting, but it brings or calculates oriental information from the logs, knot directions, for example, how the hardwood is positioned inside the log. In some products, you might want to avoid the hardwood, and in some products, you especially want to make the products out of hardwood. and then it makes sense to find the correct orientation and then use that orientation information in the sawing. That is the essential difference between these two systems. And we will do it in the saw line just before the sawing, so it will be kind of in real time as in the log sorting. So there is some solutions on the market, but they are, let's say, too slow to function in the saw line.
Congratulations for your presentation. I was focused in the last part of my presentation on terahertz because of the problems that the Spanish administration puts to the industry to install this kind of devices, and we've thought on terahertz as an alternative. So my question is, have you installed any of these in different countries, and which is your experience? For example, I've understood that the Finnish administration is always also very hard on this. And well, tell us a little bit about your experience with this. Thank you.
Thank you. Good question. We have systems in Germany, in Latvia, in Russia, in Estonia, in Sweden, and in Finland. And we have studied a lot of different species of woods. And for example, from North America, from Australia, I think 10 to 15 species. We have measured them in our own laboratory. We have more than 1,000 square meters of space, and we have almost 20-meter long measuring conveyor where we can rotate the log into 4,096 positions and run it as many times as we want. So we can draw pretty nice statistics from any log we measure. So the differences between the species or between the countries is obvious. The quality of logs in Finland is something very different compared to, for example, even Sweden or Germany. There are different, let's say, requirements from the sawmill side. They vary a lot. So it's not easy to build a kind of one system that fits all, but we have to always kind of tailor and really make research with the customer in order to solve new problems. But, well, we are up for it.
Any other questions? So I have one question. It is interesting to see that you are combining so many measurement systems in your product. Is there any still missing some technology or some needs, what especially you are looking for right now? What the customers are looking for now, especially, of course, the photonics related?
Yes, there's this eternal question, can we see rot? And I always say, I wish that too. In Germany it's easy, it's basically a hole. Of course, tomography is the best way to find a hole inside a log. We just compute density distributions and we see that there is zero density in the middle of the log, so it's pretty easy. But in Finland, the rot is somehow really, really different. It's basically not a hole, of course, and the kind of fiber structure, although it's broken or has changed, but the density is compensated by moisture. So it's basically less dense, but it's more moist. So we cannot actually detect it very well with X-rays. If there's any technology that actually can penetrate a log surface, let's say 15 centimeters, I'm really, really interested, especially if it works in an industrial environment. I'm interested in the microwave technology. I think that is not yet fully examined. Terahertz, why not? Whatever, we are open for any kind of collaboration. At the moment, we want to solve everything. So, and there's some room in the system for some more technologies. At the moment, there's only 17 cameras.
Okay, one last question. I know that there is a place also the person who are hobby is hunting. So how much this hunting affect to forest industry?
Well, we see it a lot. Actually, we can detect shotgun shots from the logs. It's pretty easy. It's like a splinter of metal or lead inside. Bullets, yes. Arrows, no, but barbed wire. The biggest which we have found is it's a metal bar used for, I don't know, working. Someone left it on the next to the tree, and then the tree kind of grew around it, and it went through our system. Beep.